I redesigned the cooling fan for 20 HP motor. So the baseline fan generated a very high noise and low volume flow rate. For that, my innovation considers how to improve the flow rate and low noise rate, and same time how to improve the energy efficiency. For that, I achieved redesign. I changed the material. Finally, I achieved and tested. It is confirmed that it is improved the flow rate and reduced the noise level, and it is having the high energy efficiency. So the technical details I'll state later. Just I'll war you the entire my patent details. So now what is the address? My patent address about the global concern about regarding acoustic emissions, particularly from turbo machines, especially axial air motors. This invention mainly aims to how to reduce the noise by maintaining the same aerodynamic performance. So my patent serves as a cooling unit for any heat dissipating units or rotational equipments, mainly turbo machineries or axial air motors. So my innovation addresses mainly how to combine, how to use the advanced engineering tools and cutting edge materials, how to combine this engineering technology and materials to achieve my goals like how to improve the flow rate and reduce the noise and energy efficiency. So that is the area of my invention. Next. So this is finally I redesigned, I provided innovative design, I changed the design, and also I applied some specially developed fiber reinforced materials. From that I achieved my target levels. So this composite material is not only give the structural integrity, it is also dampening the noise levels. So it is also improve the aerodynamic efficiency with less noise. So I compared the market available similar products. The cost is almost equal to the similar products with high efficiency. So I prepared a laboratory model, that is TRL4. I tested what is the performance levels also. After that, the patent is also granted with the number 444.0.9. So these are the three different models I prepared in a lab. So the PAN 1, PAN 2, and PAN 3 with after rigorous CFD simulations, aeroacoustic simulations, and structural simulations, finally achieved all different profiles. After that, after simulations completed, finally I selected 3 designs of 3 different variations, changing the blades, changing the design and materials. So in these 3 different materials, 3 different designs and orientations. I selected 3 models for testing purpose. So finally I tested 3 models to verify the flow properties and noise properties. From that I achieved the PAN 2 is more efficiency compared to all 2 other PAN. So next slide I'll show the performance results. So the same slide I am showing what is the major steps to implement if it is accepted, you are accepted my patent. So what are the major steps to implement the solution? The first one is design the mold separately for inner shroud, outer shroud, and blades. Then I have to purchase the materials as per my specially developed layout sequence. Then I have to fabricate the inner shroud, outer shroud, and blades by using any composite fabrication machines like vacuum assisted resin transfer molding. Then I have to assemble all 3 parts and testing. So these are the major steps to convert the lab model to land model. So these are the efficiency what I performed. These are the 2 results I presented here because of the space limit here. So what is my noise levels and flow parameters. So see the blue line, above line is related to the existing baseline design, the below line is the redesigned plan. So from that all the tonal noise levels and overall noise level is well below the existing model. And coming to the flow noise, see that overall sound pressure level of baseline fan is around 82.3 decibels in 20 Hz to 20,000 Hz. Coming to redesigned fan, the noise levels are drastically reduced to 69.5 dB only. So noise reduction is around 12 dB. At the same time, the volume flow rate is improved by 11.6%. And also the energy is also, it's consumed less power, that is around, your saved power is around 49.5%. It also overall efficiency also improved by 68%. So these are the basic parameters related to noise and flow of my redesigned pen tested in our laboratories. Then I'll go to the what is the market where applications of my patent can be used for various applications like wherever the air movement is required, like industrial ventilation. So why it is useful for industrial ventilation means it is having very high energy efficiency and quiet operation. So it is a low noise fiber reinforced remover and made with composite materials. So it will give the less noise and high energy efficiency. So that's why it is very suitable for industrial applications. Then you are going for any commercial application like office buildings and restaurants because your quiet noise and quiet noise levels is very less. So it is also very suitable for when you are using for any office and restaurant buildings wherever the air flow is required. So it is a common application for HVAC, heating, ventilation, air conditioning. So by combining effect of high energy efficiency and low noise level, high flow rate, so it can be well suitable for all HVAC systems. Not only these traditional applications, you can also apply it for any other recent application like boats, ships to get the very high compromising performance. So it is also used for recent data centers or laboratories because of it will give the minimum noise disturbance because it is only 69 decibels. It will pass the what is the Indian standard codes noise levels Indian standard codes. So this is about various applications of my product. So then what are the constraints? So these constraints, as per my estimation, it will take around 12 months to convert the lab model to land model. The funds required around the main is 15 to 18 lakhs. I estimated based on the major cost is goes to the resin transfer molding, that is a fabrication machine, and then mold preparation. Then manpower is only 4 to 6 members are enough to prepare the models. So then these are the what is the expectations required from the any you are agreed. So these are my expectations. Just I will take only 3 lakhs for transfer my license. So this is take 3 years to design, carry the simulations, and finally testing and fabricated. Almost I taken 3 years to convert this model. So then I will take only 5% as a royalty. So I will give the support, entire design, fabrication, and also testing whenever you required based on your either through digital contact or through emails or in physical visits. So these are my expectations. So next, so these are my just I will give only overview about my patent. So
Sir, sir, excuse me.
yes sir.
Sir, I would like to understand what is the technical difference in between the patent you have made for these kind of fans and the other available in the market right now.
Only thing is what is the market available, they are all using only plastics. Majorly, they are using only this type of plastic models they are using.
Okay.
I have used a special purpose composite materials and also I used some aerofoil sections that these are contributing towards major noise reduction and flow rate and high efficiency. So these are not you are going to achieve with your what is these models available in market. They are generating
Okay.
very 80 dB noise. That high noise are not suitable for when you are going for data centers or any defense applications or you are going for any other applications. So that is
Okay.
not suitable for these particular specific applications where the noise is very important and flow rate and efficiency.
Okay.
That is the
Okay.
difference between physical, what is the prototypes available in market and what is my best efficiency of my product.
Okay.
Yes, sir.
So
Yes.
the major difference is the material used in making these
Yes,
fans,
material
right?
and innovative design, both. Design and material, both are contributed because this is aerodynamic noise is contributed by design. Structural noise is suppressed by using this material chain. That's why I use both changes.
Okay. So these fans can be used as an exhaust fans, like, right?
Yes, sir. Exhaust fans. You can use exhaust fans.
Okay. Okay. Okay.
Yeah, Dr. Ramakrishna, please
Yes, sir.
talk about the speed variation you have tested for your product. And then,
My speed is, I not given technical details, sir. I tested this is for 20 HP motor. It is around 3000 RPM, sir. I tested here.
and what
It is
were the
2950 RPM.
what were the
I
results?
tested all the three redesigned models are tested at the condition.
So you expect a life of the product is as a normal product or
Yes, sir.
they,
I prepared now I prepared this model around 9 years back, these models. This is now I prepared, after getting patent, it takes around 9 years. The design will take 3 years. After applied, 2016 applied for patent, I got patent in 2023, it takes 4 to 5 years. So this still what I have prepared, the model still they are working, I tested in motor, the 9 years, they are not spoiled, any shape or any warpage, that's why any air, so that's fabrication is very important, sir. We are quality in fabrication, any airs are entrapped in the layers, that will give a problem future. If you are fabrication, there are no issues in the air gaps, air warpages, that the life is very good, sir. There are no issues with life. It is more than 10 years. It is done.
Thank you very much.
Thank you.
Thank you, sir. Any questions? So thank you, sir, for opportunity. So I request your support for your successful
Thank you, sir.
for successful commercialization of the product. Thank you, sir. Thank you.